that best goes through the data. Or scatter plot. We use it to predict values. So yesterday we spent some time and you did a very nice job of looking at stuff and you said, oh, this is positive correlation and it's strong or weak. And today, and sometimes it's harder than others, when the data is not strong, it's harder. But we're going to draw some trend lines, or most likely a trend line is going to be drawn for you already that kind of models the data. So you can see line A and B drawn below are two trend lines for this data. We'll use it in a second. Okay. One way that we tell if a trend line is good or not is we use the residuals, and that is a new vocab word that you probably don't know what it means. But it's really pretty easy, and we're going to use approximates. All a residual is, or an error is it tells me how far off the point is from the line. Okay, so a residual is the vertical, make sure you're doing vertical distance, between the trend line and data point. Okay. So when we're doing this, if it is above the trend line, we're going to make it positive because it's above our predicting line. If it's below the trend line, we're going to make it a negative. Okay. If something has, like if we add up all the residuals together, because kind of what happens is the ones that are above and the ones that are below should kind of balance each other out. Like if we would add up all our residuals, our goal would be that the aboves and the negatives canceled out. So that's one way we can predict which trend line is better. So let's take a look, and now we're going to have to approximate because we don't have like perfect scales on these graphs. So this is both the same set of data. I don't know if you can tell that. And I draw two different trend lines. Let's do the residuals, and we're going to just write them right in there. So would you, on this first line A, just kind of draw a little vertical line from that first point to the line? And I want you to approximate how far above the line the point is. Let's look at our scale here. What is the scale going up by? The tick marks are, it's here to here is 10, but each little grid mark is then a 5. Agreed?
Oh, yeah.
Okay. So if I'm looking at this, these are approximates. They're not perfect. It's less than 5. I'll call it plus, I think Addison said 2. Is that what you said? Yeah. Is it perfect? No, but we're just approximating here. If the point is on the line, then its residual is 0. Okay. All right, let's go to the next one. I have another one above the line, and I would say it's probably about the same. Maybe you could say plus 1 or plus 2. We'll go with plus 2 again. Do you see there's also a point below? And it goes a full tick mark, which is 5, and a little bit more. You want to call it 7, but it's below the line, so we're going to write minus 7. Break. What about this guy? It's on the line, so we don't do anything with that. This to me looks like it's 2 tick marks above the line, agreed?
Yeah.
So let's call that plus 10. What do you want to call this next one? 1 or 2? We'll call it 2. And how about this? All right, would you just double check and make sure that you made the ones below, the data point below the lines negative? Okay. I'm going to just quick show you what I mean by the sum of the residuals, okay? If I would add up all of these residuals, plus, let's do all the pluses first. 2 plus 2 is 4. 4 plus 10 is 14, and 14 plus 2 is 16. And over here I have minus 12. I'm just going to write up here that the sum of the residuals was 16 minus 12, okay, 4. The closer the sum of the residuals is to 0, the better the fit is what I'm saying. Okay? All right, let's do this one. Minus 10. I'm going to call that minus 10 again. Minus 5. Are you already seen which one's better? Minus 5. Whoa, this one's 5, 10, 15. Minus 15. This one was plus 10. This one I would say is plus 5-ish. And that last one was on the line. If I sum up all of these, we got, I'm going to do the negatives first. Negative 10, negative 20, negative 25, negative 30, negative 45. Negative 45 plus 10 is negative 35. Negative, okay, this has a sum of negative 30. So it's just a little bit, it's a way that we can tell if the data is a better fit. So which line is a better fit then? Line A. And the reason was the sum of residuals was smaller. Basically what that means is it has less error. If the points are closer to the line, then it has less error than the other one does. Okay. What else should we be able to do? We should be able to approximate slope. Please understand, I'm asking you to find the slope of the line. Don't take 2 points, because I'm just looking at the line itself. So if I wanted to do that, I'm going to just kind of look here. To me, that looks like it's 140. Does that look right to you? Yeah. So you can go all the way down, or maybe just go to another, I'll go to the middle here. And let's just do rise over run. So I'm going to figure out how far down and over this went. They just have to be on the line. Just on the line. So I could have done, and it's approximate, I could go from here to here if I want. Okay. As long as I use points on the line. Okay. And if there are no points on the line, make some up, because it's an approximate. So to me, I saw that this is 140 and it goes down to 125. How far down did it go? And it went down. So I'm going to do for on my top negative 15. And just really be careful of the scale here, guys. I went over from 0 to right here, which is 30. It looks to me like this has a slope of negative 1/2 or negative 0.5. What does it mean in this data? Well, let's read. I should have maybe done this at the get-go. The scatter plot below displays the same data and the age of 8 health club members and their heart rates during exercise. Okay? So what happens at this health club as a person gets older? When they're exercising, their heart rate also gets lower. There could be different reasons for that. Maybe they're not working hard. I don't know. All right, but what this slope means is -5 is the change in heart rate over the change in age. So every year a person gets older, on average when they're working out, their heartbeat is a half beat lower. Okay, 4. We already did this one. Using line A above, give the amount of the residual at 40 years. Let's find the dot at 40 years. We already found what its residual was. It's that one. So do you see the 40? This is the point and this is the line. The error or the residual we got was positive 10. Okay. One other thing that we could do then is going back to lines, we could model with a equation, y equals mx plus b. Remember that? Didn't we just find our slope? If you looked at the graph, what would the y-intercept of line A be? Where is this? 140. So we could say that's y equals negative 0.5x plus 140. Okay, so that's what we're going to do next on this one. All right, let's look at our scale. Let's find 2 points on the line. Are you cool with me starting right there? Because that's going to help me when I ask for the y-intercept. Why don't we just go ahead and use the last one on the line? All right, let's see. What's the rise over the run? All right, you tell me, rise. This is 6 and it goes to 10. Or yes, not you're right. This is by going up by 0.5s, isn't it? So 7.5 to 10 would be 2.5.
Yeah.
Okay. It's going up 2.5, and all the way over it went from 0 to. Yeah, actually, this is 10. This would be. But this scale is by ones. So 11. All right. Well, yeah. All right. Would you divide, let's get a decimal approximation. What's 2.5 divided by 11? I got 0.23-ish.
I got 1.2272.
Yep. Okay. Now I'm going to round to 2 decimal places because this is money, and so this would represent cents. Okay, so what this means is for every month the employee makes 23 cents more. And that's per hour. So every month that the employee's there, they're getting a 23-cent month raise, essentially. What is the y-intercept? 7.5. The y-intercept would represent the starting salary, okay? I know that must be old because this is below minimum wage. So the starting salary when they're first hired, employees make $7.50 an hour. The equation for best fit then? Well, y equals 0.23x plus 7.5. Or if we wanted to be more fancy and put in variables that made sense, we could say their rate equals 0.23 times the number of months they're there plus 7.5. Okay, residuals. Let's do it. We're going to put the residual at each point. Did you guys remember how our scale on the y's was 0.5? Yes. What would you call the residual for the one at 2 months then? It's below the line.
The negative.
Negative 0.5. This one's slightly less than a tick mark. What do you want to call that?
3.
Sure. Positive 0.3. How about at 4?
I would say I had
I would say it could be negative 0.4, negative 0.5. It's a little more. This one, next one's a little less. So maybe I'd call that one negative 0.3. Do you see there's another one at 6? There's 2 employees, they make different values. That's not fair. How far is it off on the top end? That looks like to me by 1. Because it's 2 tick marks. You could even make an argument for a little more than 1. We're going to assume, since it's that close, that that one's on the line. How about 8 months? You mean 0.7? Because each tick mark is a 0.5.
Oh, yeah.
Point. That's very important. Don't drop that. And then I'd call that +1. So really what you should be able to tell me is how far the data is from the prediction. The line would be used to predict, the data would be the actual point. Okay? All right, here's what you're doing on your own. I don't think we might get to page 15. We'll see. What we have here is I have some data from the age of people. So these are their ages. And they all had knee surgery. And it is the range of motion after their knee surgery. Okay, so these are the actual points. They are plotted below on the graph. Make sense? On your own, can you please find the residuals? Now be careful because this table is out of order. So like, for instance, at, oh yeah, this is 14. What would you say, how far is 14 off the line? It's pretty much on the line, isn't it? So up here for the age of 14, the residual is 0. So which point do you think this one is? Look up on the table. Which age is that one? 16, and let's see, what are these going up by? 10s, I think. 10, 20, 30, 40, yes. And so this one to me looks like it's probably, if they're going up by 10s, I would call that 20 above the line. Okay, would you finish that for me, please?